Everyone, okay, so in this video we are going to see on how to do differentiation in trigonometric function. So as we know, we have 6 basic trigonometric function, but for the differentiation I'm going to focus on 3 formula, which is the first one. Let's say if we want to differentiate with respect to x the function of sine x, where the value of x here represent an angle of the trigonometric function. So we are supposed to get here cos x. This is the formula, the first formula that you need to know. And the second one, if we try to differentiate cos x, so here we are going to get a bit different value, which is we are going to get here now sine x, but it must be in terms of negative. And one more, if we try to differentiate for the tangent x, it will be secant of x. So usually I'm going to put a bracket for each value of x there. So where the value of x can be represented in terms of degree, or sometimes it will be written in form of radian. Okay, so based on these 3 formula, basically we are going to see on how to deal with the example of differentiation here. Let's go for the example number 1. Okay, let's say here the question asks you to find the dy over dx for, which is it asking for the differentiation of the function for the first one, y equals to sine 3x. So in order to do this, basically we are going to follow the first formula. So if we try to differentiate for sine x here, our output should be cos x. So here we can actually try to get the same answer there, which is sine x, we are supposed to get cos x. So sine 3x should be cos 3x. But please pause for a minute, because here we have 3x, so here we only have x, so it's a bit different there, where here we need to differentiate for the value of our 3x there. So here we are supposed to again differentiate the value of 3x here, which is if we try to differentiate for 3x, we are supposed to get 3. So the value of 3, you are going to put it in front of this. Okay, same goes if we try to differentiate, for example, y equals to sine, let's say here sine with pi x. So since the value of pi here is a constant, so we are going to treat it the same properties as the number 3 there, which is you are supposed to get the value of your dy dx. Again, if you try to differentiate sine based on the formula, the answer will be cos, so it will be cos pi x. But here you need to again differentiate the value of pi x, so you are supposed to get pi in front of it. So this is the first basic techniques that you need to know. Okay, I hope you can try to understand it better once you deal with the exercise later. Okay, now let us have a look into the differentiation part. Let's now try to see the implicit part of the trigo function. For example, here you are given the value of x plus with For example here, cos xy equals to 3. Okay, so for this kind of question, if you want to find the dy dx, so now let's say the question asks you to find the dy over dx, we are going to use implicit differentiation since we are dealing with two functions, which is we have the value of x and also we have the value of y in one equation. So here we are going to apply the implicit differentiation. I think you should go back and try to see how does the implicit differentiation works. So now we are going to deal with the variables with respect to x. So differentiate for value of x, we are supposed to get 1. And if we try to differentiate for cos xy, again we need to go back to our second formula previously, which is if we try to differentiate for cos x, the answer is supposed to be negative sine x. So here what we are going to get, we are going to get a negative of sine x. So here will be the negative of sine of x and y. But it's not enough with this function. Basically, we need to differentiate for the value of xy here. So you need to differentiate this part. So if you see here, in order for us to differentiate this part, we are required to deal with what we call as a chain, it's not chain rule, it's supposed to be a product rule. So if we want to differentiate for the value of xy, x dot y, or x multiplied with y, we are supposed to use what we call as a product rule, where you are supposed to find what is the value of your u here. So the value of u will be x, and the value of v will be y. So u prime should be 1, and the value of v prime should be 1, because you are differentiating the value of y is supposed to be dy over dx. So use the formula of product rule, which is u v prime plus with v u prime. So you are supposed to get here u multiplied with v, so you are going to get x dy over dx, and here 1 multiplied with vu prime, so it will be y multiplied by 1, so it's supposed to be y there. So you are going to take all this value, you put it here. So all this value, you are going to put it somewhere here, which is the value should be x dy over dx plus with y. And if you differentiate 3 here, of course you are going to get 0, so just put it as 0 there. Okay, let us see next. So you just need to regard this one as one function, so differentiate it with x and then differentiate it with y. So you are going to get a new function here, which is 1 minus with x sine xy dy over dx. Always put the dy dx at the back of it. So then you are going to get here y, so it will be minus with y sine xy equals to 0. Since we are going to find only dy dx, so we are going to bring this part to the other side. So you are going to get here 1 minus y sine xy. So this part you are going to bring to the other side, so it will become a positive. So it will be x sine xy dy over dx. So the final answer for this will be, this is actually a multiplication. So you are going to get, if you bring this part to the other side, it become a division. So you can say that therefore the value of dy over dx is equals to x sine xy over 1 minus y sine xy. Okay, I think I have give you a few exercise in the implicit differentiation, and also you also will encounter the question in your assignment. Okay, so you can try this kind of example in the exercise and also assignment. Okay, if you got any question, try to reach me by using a telegram. Okay, so see you. Thank you, class.